Section B, question 8. When hexadecane is heated to a high temperature, one molecule of hexadecane, C16H34, decomposes to form an alkane containing 8 carbon atoms. And alkane, now alkane is CnH2n plus 2, so it can't be 8 carbon atoms and 2 different unsaturated compounds. 2 different. In this case, we've got 3. So it can't be C, so it's either B or D. Unsaturated compounds. Let's see if the hydrogens are balanced. 18 plus 10, 28 plus 6, 34. 18 plus 14 plus 2. 18 plus 14 plus 14 plus 2 is 34. But it says 2 different unsaturated compounds. So the answer is going to be two different unsaturated compounds. Unsaturated. So that tells me that it's just going to be like an alkene, CnH2n. So it's actually going to be C. C8H18, C2H4, C4H8. It doesn't say, it says 2 different. It doesn't say 2 overall, it's just 2 different. So yeah, the answer is C. Bit of a tricky one. What statement is correct? Kerosene is a mixture of compounds. That is absolutely correct. Which statement about polyethylene is correct? It decolorizes bromine water. No, because polyethylene, well, it's not going to have any carbon-carbon double bonds. It has a lower density than ethene. It has a lower relative molecular mass than ethene. It has a higher melting point than ethene. That is absolutely true. Which statement is not correct? Which statement is false? The monomer is propane nitrile. If you draw this out, see the one C H2 HCN. Yes. Propane nitrile, that is not true. The molecule is unsaturated, yes. Got carbon-carbon double bonds. The monomer is an additional polymer, yes, that's true. The monomer has a repeating unit, yes, that's true. Exactly why I drew it without the double bonds and obviously sticking out of the carbon-carbons. Which alcohol, when dehydrated, forms a mixture of alkenes? Now with propan-1-ol, it's not going to form a mixture of alkenes. Same with propan-2-ol. So left with propentan-1-ol and pentan-2-ol. And the answer is going to be D-pentan-2-ol. It's a repeat question. Which compound has the highest boiling point? Generally, like I always say, 9 times out of 10, we're looking for the one with hydrogen bonds. So A definitely doesn't have hydrogen bonds. Same with D, because with hydrogen bonds, remember, electron deficient H atom is bonded to nitrogen, oxygen, or fluorine. In D, we don't have nitrogen, oxygen, or fluorine. And so there's either B or C. Let's draw out C and just show you guys. CH3, CH2, CH2, CHO. So it can't be C. CH and then obviously C double bond O. It's not C. The answer is obviously going to be B. It looks like it could be C, it's not. Because you've got the CH, so the oxygen is bonded to the carbon, the hydrogen bonded to carbon, they're not bonded to each other. So the answer is B. Which statement about molecules in a gas is correct? At a fixed temperature, they all move at the same speed. Incorrect. At fixed temperature, the average kinetic energy is constant. That is true, so that is correct. Let's look at the rest of them. As temperature increases, the more molecules with the most probable energy. No. As temperature decreases, fewer molecules with mean energy. No. More molecules with the most probable energy as temperature increases. No, that's not true. Which compound produces this when oxidized? Now, what is this? This is a ketone. Let's draw out the structures of each of these. Methane, ethane, propane. Alcohol group on the first carbon, methyl group on the second. Try to do a bit smaller so we can fit all 4 structures, and it's also not too messy. Then we've got 2,2-dimethyl propanol. Methane, ethane, propane. Alcohol group CH3, CH3, H, 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 H. Then we've got, 2-methyl-butanol. Methane, ethane, propane, butane. 2-methyl butanol. Then we've got 3-methyl-butanol, methane, ethane, propane, butane, alcohol group on the second carbon. We've got a methyl group on the third carbon. H, 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 H. So if we look at these, for A it is a primary alcohol. B it is a primary alcohol. C it is a tertiary alcohol, so it definitely can't be oxidized. So I can already cross C out. And D is a secondary alcohol. And obviously, what is this? This is a ketone. I was just a bit confused whether it's a ketone or aldehyde. It's obviously a ketone. It's got the C double bond O in the middle of the carbon chain. It is a ketone. And secondary alcohols are oxidized to ketones. Therefore, the answer must be D, because that is a secondary alcohol. That's the only secondary alcohol. Which reaction does not result in a change in the shape around the carbon atom? Chloromethane with aqueous sodium hydroxide. With ethene with bromine, that definitely would. Alkene, bromine, propane with excess oxygen, and propan 1 always stood for potassium dichromate. Yeah, so answer is A. Question 17. Which compound has the same empirical formula and molecular formula? Okay, so butane. Okay, we're gonna have to draw them all out, I guess. Methane, ethane, propane, butane. Methane, ethane, propane, butane. Fill in the hydrogens. So it's going to be, we'll just fill in the hydrogens. Ethane, ethane, propane, butane. C4, 1, 2, 3, C4H10. C4H10, yes. Butanone, methane, ethane, propane, butane, but it's got a double bond on the first carbon. So we've got this. And obviously, because we've got the double bond, we lose 2 hydrogens, so we're not going to have those 2 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8. C4H8. Propane, methane, ethane, propane. C3H8. Let's just draw it out for you guys. Methane, ethane, propane. can see C3H8, and propene, methane, ethane, methane, ethene, propene, C3H6. Can't cover the bond anywhere really, and obviously we lose 2 hydrogens atoms because of that double bond. So it is 1, 2, 3, 4, 5, 6, C3H6. And it says which compound has the same empirical formula and molecular formula. So if it has the same empirical formula and molecular formula, it can't be simplified. Can that be simplified? Yes, it can, to C2H5. Can that be simplified? Yes, to CH2. Can that be simplified? No. You can't divide 8 by 3, and that's not a simplest whole number. And that can also be simplified as well. So the answer is C, propane. Which is the expression for Kc for this equilibrium? Remember, Kc So question 18 is just testing, can you construct Kc equations, products or reactants to the powers? We don't add them, we just leave it like that. So in this case we times them. In this case it's a bit more tricky. Instead of constructing an equation, an expression for Kc, we want to find equilibrium moles. So we've got carbon monoxide, hydrogen and methanol. And it tells me that initially, I stands for initial moles, C stands for change in moles, E stands for equilibrium moles. Initially we have 2 moles of carbon dioxide mixed with 3 moles of hydrogen. So therefore, it doesn't tell us the moles of methanol initially, so we assume it's 0. And equilibrium moles of methanol is 0.6, so we add 0.6. Therefore, if we add 0.6 on this side, we're going to subtract 0.6 on these sides. 1.4, but in this case it's a 1 to 2 mole ratio. So instead of subtracting 0.6, we're subtracting 1.2. So we should get 1.8. Now if we add that together, the equilibrium moles, 1.4 plus 1.8 plus 0.6 should give me 3.8. Because 1.4 plus 0.6 is 2, 2 plus 1.8 is 3.8. Which change in condition will decrease the equilibrium yield of methanol? Increase the surface area of catalyst. Remember, catalysts have no effect on the equilibrium yield. So even if we increase the surface area of it, it's not going to affect it. So now we're left with this. Decrease the equilibrium yield of methanol. Methanol here. Forward reactions exothermic. So what was one of the options? Increase the temperature. Increase the temperature, it's going to shift to side. It's going to shift to the endothermic direction, the opposite direction, to oppose the increase in temperature, to decrease temperature, and therefore it will decrease the equilibrium yield of methanol. So the answer is D. And if you look at B and A, if we increase the amount of CO in the mixture, it's going to oppose it by increasing the amount of methanol. That one's clearly no. And if we increase the pressure, it's going to shift to side with fewer moles of gas to decrease the. If we increase the pressure, we're going to want to decrease the pressure, shift to side with fewer moles of gas, which is the right hand side, so it's going to actually increase the equilibrium yield of methanol. So therefore the answer is still D. When 2-bromobutane is warmed with potassium hydroxide solution, substitution and elimination reactions both occur. Which of these compounds is not produced? 2-bromopropane. So what I would do is get a piece of scrap paper, just go through the mechanism. And I might just do that now. Methane, ethane, propane, butane. Bromo group on the second carbon. Two bromobutane, one potassium hydroxide solution, OH minus. Now let's go through the alcohols. Attacks partial plus carbon, CBr bond breaks, and what happens is we've just got an OH group here, or hydroxyl group. And the Br leaves with a lone pair of electrons, and it's still negative, and it's now negatively charged. Overall charge stayed the same. So what is that? That is butan 2-ol, not butan 1-ol. You can't form butan 1-ol because the Br group is on the second carbon, and all we're doing in nucleophilic substitution is replacing, that group. So in this case, we're replacing the Br group with the OH group. So it cannot be butan 1-ol. Yeah, it is butan 2-ol. It cannot be butan 1-ol. If it was 1-bromobutane, then it would be, but it's 2-bromobutane, so we don't form that. And therefore, yeah, I didn't have to even look at the elimination reaction. What is the role of hydroxide ions in the elimination reaction? Now remember, with nucleophilic substitution and elimination reaction, with nucleophilic substitution, the OH minus ions acts as a nucleophile in aqueous conditions, and what happens is they act as a nucleophile, whereas with elimination, this is the elimination, OH minus ions acts as a base. So it's just a key fact. I'm gonna 1 second, guys. I'm gonna go through a bit more on this difference between nucleophilic substitution, elimination, and conditions. Yeah, so if you are using OH minus water in reflux, you form an alcohol in nucleophilic substitution, aqueous conditions, and then it's nucleophilic substitution, and the OH minus acts as a nucleophile. Whereas if you use OH minus ethanol in reflux, anhydrous conditions, you form an alkene, and OH minus ions acts as a base in the elimination reaction. You do need to know the key differences, and that is the end of the multiple choice questions.